8M2 Lesson 2, Definition of Translation and 3 Basic Properties. This builds on yesterday's lesson, 8M1, 8M2L1. Let's get going with this in just a second. We will cut on over. And here we are. All righty, let's go. All right, so remember yesterday we talked about taking objects, and let me just, I'll just do this for you. We took an object like this, and we could, a triangle, and we could move it, and we still preserve, you know, that triangle, the shape of the triangle. We could twist it or turn it, rotate it, or we could, and watch me what I do carefully, I could flip it, right? So I could, this is a, flipping is called mirroring. It's also called reflecting. So those are the 3 things that we could do. We had fun with shapes. We didn't go into too much depth on any one of them. But today what we're going to do is we're going to focus on just the first of those options. Remember we talked about moving, which are sliding. We talked about rotating or twist. And then we talked about flipping or mirroring or reflecting. You know, reflecting like a mirror. And all of these are 3 different things that you can do. So what we're going to do today is we're not going to do rotating or twisting or flipping or mirroring. All we're going to do today is moving and sliding. And the technical word for that is translation. Okay, now when you're translating, it's okay to simply, again, move, whoops. We can move it down. We can move a triangle to the right, but notice how it's still kind of always upright. That's all we can do when we're translating. And there's some interesting properties of translation, which we'll talk about in a little bit. But these are all valid translated triangles from this first triangle, right? So in translating, we cannot, in translating, when translating, there is no twisting, no rotating, which is the same as twisting, no rotation, and no reflecting or mirroring. No reflecting, no mirroring. Okay, so if something's upright and we translate it, it will always remain upright. Now, the interesting thing about translating is this next notion, which is called, if you translate along a vector. A vector. And a vector is a distance plus a direction. And why do I talk about that? Now watch what I do. Watch this. This is really cool. So the thing about translations, when you think about sliding something, there's an interesting property. And that interesting property is that each point that's been translated on that same shape, each point is moved the exact same distance in the exact same direction. So if I look at these three arrows, now watch what happens. If I take these three arrows and I move them I'm going to move it here, and I'm going to move this other one right here. And I'm going to move this other one right here. Notice that they're all the same. The only reason they're slightly off is because I didn't draw them perfectly. But the distance from point A to point A, and really I should call this for, yeah, some of you I think are going to catch this. I really should call this point A prime, B prime, and C prime to use our terminology from yesterday, because A is not the same point as A prime because I have moved it. So I am talking about taking triangle ABC, and I am translating it to triangle A prime, B prime, C prime along vector, and I'm going to call it XY. Translating along vector XY. And again, because every single point here on this shape has been moved the same. Yeah, you can see that that one's a little bit longer, but everything will have been moved the same distance. So let's look at an example. So these are called vectors, right? So this is the vector. Let me draw that little arrow. Right? That is my vector. And in this case, you could call the vector, well, we could call it XY, XY, and we could actually take that vector, and because vectors just have a direction and a distance, don't let this confuse you. If it's confusing you, just ignore it. But I'm going to say that this is, vector XY. And vectors just have distance and direction. So you can take a vector and you can move it around, which is what we've done here, here, and here. We've moved it around, and that's still the same vector. Vectors don't have a starting place and an ending place. They just have a distance and a direction. So if I take a point, and I could take a point over here. I'll just take this big point here, and if I wanted to, and I could take this vector, and I could take this vector, and I could translate this point. And if we call this point point Z, I could translate it along that vector and get a point Z prime. And that's the same distance and direction as B is from B prime, C is from C prime, or A is from A prime. So let's use this concept of vectors and translation and move forward and try one more exercise. So let's take another shape. Let's take kind of a crazy shape. Let's take this shape here. No, let's take this star shape. Let's not fill it. It'll make it easier. Whoops. Let's take this star shape and let's not fill it. And we're going to translate it. We're going to translate this star along vector XY. Now, vector XY, I'm just going to draw one here, and I'm going to call it, now let's make it blue. Now let's make it yellow. Yeah, let's see if it's the same. So here we go, X, Y. So we're going to translate this guy along vector XY. So watch how we can do this. We can take our point. We're going to take each point, and rather than move the whole star this amount, which is kind of what we're doing, we're going to look at each point and translate it along this vector. Now, one easy way to do that is you can just take the vector and take a number of key points. Let's label these points. Let's label the points. We'll label them in blue. A, B, C, D, E, F, G, H, I, J. Now I don't have it's hard to kind of use a ruler on this screen, but what we'll do is we'll just make copies of this guy, this vector, and we're just going to move it around. So we're going to take the vector and we're going to put it here. And now that's C. Notice how that's point C. And you can do this with a ruler on your own screen, right? You can just take a ruler and take a piece of paper and you can mark, or a piece of transparent paper, or maybe a ruler or something, but you need to make sure that it stays in the same direction and the same length. And then we're going to make a C prime, because we started with point C for some unknown reason. So we're going to put that point here. We're going to call that C prime. Now we're going to make we're going to find D prime. Watch how we do this. So that's going to be D prime right here. You can fast forward the video if you want. This is going to take me a little bit of time. So I recommend you just fast forwarding the video and you'll see where I get to by the end. I'm just going to be taking that same vector and I'm just going to be moving it along. And just go ahead, fast forward. Just get to the end of this. This is going to be a little bit cumbersome and boring. I probably should have chosen a different shape, or one with less. You know what I'm going to do? I'm going to cheat a little bit, and we're going to here we go. We're going to keep going here. And it's not going to be perfect because I don't have these vectors down exactly right. But they're kind of close. Oh hum, humdy dum, humdy dum. All right, here we go. Let's go ahead and make our points. Hopefully you're not even listening to me at this point. Hopefully you've got this thing down. You've already fast forwarded to the end. J prime, H prime, I prime, G prime. Now let's see if we can make some lines here. I'm going to go ahead and use my line tool. Get rid of all these vectors. Don't need them anymore. Let's see what happens. Let's see what happens when we do our lines. So A goes to B. B goes to C. C goes to D. D goes to E. It's not going to be perfect because I didn't make exactly perfect lines, but you'll get the idea. And G goes to H. H goes to I goes to J. And J goes to A. And that's a pretty good job. We did a good job. So let's see. So we basically did a translation. So what did we do? We translated our star. We translated, whoops, let's get done with that. We translated our star along vector xy, and we got our new star. So that's how we do translations. We pick out all our points and we move them along a vector. Okay, so let's look about the three basic properties. Let's just write this on here while we're sitting here. Let's write our three basic properties of translation, and you'll see them here. The first is that translation maps line segments to line segments and angles to angles and, you know, rays to rays. We don't have an example of that here. Okay, and you can see that. So let's find a line segment. So we have AB is mapped to line AB. Yeah, there we go. This line segment is mapped to this line segment. BC is mapped to BC. Let's look at another one. How about FG? Line segment FG is mapped to line segment FG. Yeah. So you can find every single line segment is mapped to another line segment down here in our translated star. Number two, we have the lengths are preserved. Of line segments. So you could figure this out. Not only is AB mapped to line segment AB, but they're the same length. So the length of AB, you know, equals the length of A prime B prime, and that shouldn't have a. Yeah, let's do that. Right, and the same thing is H prime. You know, H I is equal to H prime I prime. The length, so the lengths of the segments, they're the same number of segments in the original, in the translated version, but also all of the pieces, all of the line segments have the same length. And third, all of the angles measure the same. Or in other words, i.e., they are preserved. Right, so this angle here is the same as this angle here. You know, this angle here is the same as this angle here. You know, even these outer angles, right? These angles here are the same as these angles here. So those are our three basic properties of translation, and they make sense. They're kind of intuitive. I mean, this star is the same as that star. It's just moved over here. All the distances are the same, all the lengths are the same, and all the angles are the same. Okay, now let's go to a little homework help. So this is homework help. Okay, so let's do this. So we want to, let's just make sure we can do this. We already did an example like this. Translate point E along vector QR. Okay, so I'm going to draw you a point E, and I'm going to draw you a vector QR, and I want to translate E along that vector. Now don't get confused. This doesn't mean move point E up to Q and then move it over to R. Remember what it means. Vectors are just a distance and a direction. So try this one out and I'll explain it. So you pause and try. Pause and try. I'm waiting. Okay, now we're back. Now this is hopefully a very simple problem. All you're going to do is you're going to take this vector and you're going to line it up. You're going to line it up right here on point E, And at the end of point E, you're going to draw a point and call that E prime. And what you've done is you've translated point E along vector QR. Straightforward? That's what that means. Okay, so let's just do one more, and then we'll be done for the day. And that is going to be to draw, this is a little bit harder, but just bear with me. We're going to draw a 2-inch square. Each of these, let's pretend these are each a quarter. Let's pretend that's an inch. 4 boxes equals 1 inch. Okay, so draw a 2-inch square. B, move it 3 inches to the right and 3 inches down. And then C, draw the vector that represents the translation. Okay, now when you move it, draw a 2-inch square, and let me also add to this, and then label it. Label A, B, C, D. Label it square A, B, C, D. And then I want you to label the translated square. All right, I'm going to pause, and try. Okay, so let's assume you're back. So I'm going to draw my square. I'm going to do it freeform, freehand, okay? So we're going to start, we're going to move it here. We're going to go 1, 2, that's 1, 2. 1, 2, 3, 4, 1, 2, 3, 4. Eight. And we're going to label it A, B, C, D. Remember, we label, when we label a square, we label it in order as we go around it. We would not label it A, B, C, D. This is not square A, B, C, D. You have to label it going around like this. Now we're going to move it 3 inches to the right and 3 inches down. So that means every point's going to have to go 3 inches to the right and 3 inches down. So we're going to draw our new one in light blue. So there's 1 inch, 2 inches, 3 inches. We're going to have to move every point 3 inches to the right and 3 inches down. So there's 3 inches, 3 inches, 1, 2, 3. So this is our new point A. And we're going to call it what? Right, A prime. B, we're going to move it 3 inches to the right and 1, 2, 3. And that's B prime. C, we're going to go 1 inch, 2 inches, 3 inches, and then 1 inch, 2 inches, 3 inches down. And then finally, we're going to label our D prime. And so there's our new square. Now we're kind of going backwards a little bit, but we're going to label it. We're going to now show the vector that represents this translation. So we can, which one are we going to choose? A, B, C, or D? And for those of you who said it doesn't matter, you have it. You are right. So let's just start here with D, and we'll just call it, there's our translation. There it is. And we can test it. Now we're really done at this point. We're really done. Right, there's the translation. We've translated it. That's 3 inches to the right and 3 inches down. But what we can do is we can copy it and just verify that we're not crazy. And we get, look, we must have made a mistake because it did not translate correctly. So what did we do wrong here? 1, 2, 3, 4, 5. We did not correctly go down. This is not a square. So we made a mistake here. So let's correct that mistake. So let me just go, we could go, we made a mistake. We go, boom, mistake. We identified the mistake, but we have to turn this guy into a happy cat. So we're going to go back. Whoops. We're going to go back. We're going to see where we made our mistake. So 1, 2, 3, 4, 5, 6, 7. D should have been, if this was a correct square, we would have had it. D should have been here, and C should have been here. You can fast forward if you want while I go through the exercise of correcting it. Now, 1, 2, 3. And so this whole guy, I'm going to cheat a little bit here. And we're going to select this guy. And we're going to go down 1. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. All right, so let's do our check. Make sure we got this right. We're going to do our vector starting at D, going all the way to D. If we make a copy, we should be able to check and make sure that all of our points are correctly translated. Good. B is correct. And let's make sure C is correct. Yeah. Okay, good. So we're going to go back and we're going to turn that guy into a, we're going to go back and we're going to happy cat. We're going to put a happy cat right over the top of our fireball guy, and we're just going to paw him out. Rawr. Okay, and we're going to spin the happy cat. We're going to twist him, and we're going to spin him right on top of that guy. All right, good. We are done. We have learned about translation, the 3 basic properties of translation. And we will end this lesson on that solid note. We're back. We'll see you tomorrow. We're going to continue on talking about transformations and various kinds of transformations you can do. And hopefully this is all making sense, and hopefully you're enjoying it. You're welcome. Let me know. Subscribe. Give me the thumbs up if you like it, thumbs down if not. All right. Talk to you later. Bye.